Day by day, as the climate change crisis continues to take its toll on Earth, our chances of recovering from global warming dwindle. And perhaps the largest contributor to this crisis is none other than fossil fuels. In fact, if you're watching this video on a computer, manufacturing your laptop took approximately 331 kgs of emissions. But with this ever-expanding demand for high-powered energy, will we ever find a way out of climate change? The solution is small, literally, but it has the potential to drag us out of climate change. A uranium atom is the key to renewable energy, as uranium is extremely dense in energy compared to other fuel sources. Nuclear fission mediates the process of harnessing the energy of atoms. Neutrons are fired towards uranium atoms, which decompose and split up, thus releasing even more neutrons that continue to collide with more uranium atoms. This takes place as a chain reaction and emits heat in the process. As we know, heat is a simple form of energy. The heat is then converted into steam, which flows through a turbine. The turbine then spins a generator. Generators generate electricity when they are turned due to magnets placed inside the generators. Many communities refrain from making use of nuclear energy due to a phobia of radioactivity. Perhaps this notion of nuclear energy being dangerous may have emerged from nuclear energy's relations with nuclear bombs used during the Second World and Cold Wars. However, nuclear energy doesn't have to be used for destructive purposes. The promising technology has the potential to drag us out of climate change. So far, there have only been 3 major nuclear accidents that have been a cause of destruction. 3 Mile Island, Chernobyl, Fukushima are the largest accidents that ever occurred. All 3 of these accidents resulted in an overall death toll of 31 deaths. More deaths may have taken place due to indirect results of the accidents, but less than 50 deaths have been the result of nuclear disasters. Moreover, all 3 of these accidents only occurred due to human errors, not due to the energy itself. Take, for example, fire. We know that fire is dangerous. We know it is a cause of mass destruction, but perhaps without its warmth and release of energy, mankind could have never thrived. Regardless of our mindset that nuclear energy is unsafe, statistics demonstrate that in fact, compared to other sources of energy, nuclear energy is relatively safer and harmful to a smaller extent than fossil fuels. In fact, for every terawatt of energy produced, brown coal is responsible for almost 33 deaths, compared to a mere 0.07 deaths for nuclear energy. This implies that nuclear energy is about 467 times safer than brown coal. Often, safe technologies are not entirely efficient and reliable like solar power and wind power. On the contrary, nuclear energy is quite safe, but also extremely energy dense and entirely dependable. For every 1,000 megawatts, nuclear energy facility requires a mere 1 square mile to operate, compared to a staggering 360 times more land for wind energy facilities. This implies that nuclear energy takes up less space, which means we can create more of the plants. Why waste so much excess land for other renewable sources when you can produce the same energy with barely any land? Also, uranium is extremely energy dense. This means that in a small amount of space, the chemical contains a high amount of usable energy. Suppose a single nuclear reactor can produce just as much energy as 3 million solar panels. At a first glance, it may seem like the cost for building a nuclear reactor may seem high, but maintaining a nuclear reactor is somewhat cheaper than various other methods of generating energy. Nuclear plants are designed to stay safe, and safety measures are always applied. With granular structure and intricate blueprints, nuclear energy is quite safe. Choose any 100,000 workers working in a nuclear plant, and you will only find one that has suffered lethal consequences of working in the plant. Despite the safety of the technology, nuclear energy still comes with its consequences that can prove itself to be humanity's end. In the process of nuclear fission, some radioactive byproducts can be released. This toxic waste is harmful to our environment and human body as well. The particles emitted by the byproducts can mutate and alter our DNA and kill cells. This is a potent threat to our body, as these malignant consequences of being exposed to radioactivity could lead to cancer and other potential diseases. Water is used to cool products in nuclear fission. This water is exposed to radionuclides, particles that are radioactive. This contaminated water is contained near water in containers. The problem is that if the containment chambers are defective, or if they develop cavities within them, contaminated water may leak and contaminate surrounding bodies of water. If the chamber is underground, the leak may find its way to the water table and contaminate everyday drinking water. The next thing you know, you might be taking a sip of radioactive waste the next time you take a quick drink. As stated previously, this can lead to genetic mutations and damage your body severely. Climate change is a global problem. No one solution can finish it. To counter this problem, we will have to implement a multitude of different technologies. However, in this quest for ending climate change, nuclear energy has proven itself to be a vital asset. With its astonishing energy capacity and its staggeringly low carbon footprint, we may never have a technology so promising. And if we fail to slow down climate change, we may have to resort to nuclear energy anyways. No technology that is promising will be entirely safe, and perhaps no technology that is entirely safe will be promising. As we face climate doom, nuclear energy may very well be the best ally we have.